Now consider at t equal to minus 1. Just do the same. We have only two criteria that we can use to check. Okay. So now our t0 is equal to minus 1. I put a criteria first. And then we just plug the value as the criteria, as our criteria. Okay. So now our t0 is equal to minus 1. Because our t0 is to minus 1, you plug it in here, you would get what? T plus 1 pt. Be careful about the sign, okay? So we would get t plus 1 times our pt is t plus 2 divided by t minus 2 times t plus 1 squared. Cut it out. You would get t plus 2 divided by t minus 2 times t plus 1. With this function, if you plug t equal to minus 1 in here, can you find the value of this function? You plug minus 1 in there. No, you can't. So this one you might guess that t minus 1 is an irregular singular point. We check this one again. T plus 1 square, t plus 1 square minus t plus minus t minus 2 square, t plus 1 square minus t divided by t minus 2 square. Now, if you plug t equal to minus 1 in there, can you find the value of this function? Yes, you can. But since with the first function we said that for the criterion, it's got to be analytical for both functions. We use and, not or. So, in this case, since for the first criteria, it's not true. So, we can conclude that t is equal to minus 1 is an irregular singular point. So if you want to find the answer, or if you want to find the solution for the differential equation around the point that t is equal to minus 1, you can do it because it is an irregular singular point. But you can find the solution for t equal to 2 because it is a regular singular point. And like I said, this method we call Frobenius method. To find the solution at x0 is a regular singular point. We are going to assume y is equal to summation an x minus x0, where r is a constant, and we've got to find r ourselves. And this answer would be true in this range. And the method that we are going to use is called Frobenius. We are going to use the Frobenius method to find the solution around the regular singular point. And by that, we got to assume that y is equal to summation of an x minus x0 to the power n plus r. And r is a constant. And r is finding from integral equation สมการดัชนีอะค่ะ That's two ways that we can find the integral equation. One, they have the equation for you, or if you cannot remember it, another thing that you can find is that when you plug the y that you assume here into the differential equation, you will get the integral equation from when you do the compare the coefficient. I'll show you in the example, but just write down the equation to find the integral CIAL. Said that if we have the differential equation like this, okay, we say that the integral equation is r times r minus 1 plus p0r plus q0 equal to 0. We find r from this equation, and we find p0 from the limit x equal to x0, go to x0, so x minus x0 times px. You find this term, and you plug x equal to x0 in there. You would get p0. For q0 equal to limit x go to x0 of x minus x0 squared qx. It's just whatever our criteria that we are using to define whether our singular point is the regular or irregular singular point. Okay? With the criteria itself, you plug the x value equal to x0 into these two functions, you would get p0 and q0. When you got p0 and q0, you just plug it into the integral equation. This one is called integral equation. This one and this p0 and q0, you would get the number. You would get it as a number, it's not a function after you plug the value of x to x0 in there. These two will be the number. You put those two numbers into the integral equation, then the only parameter left in this equation is r. You would get two value of r from here. Okay? And then just define r1 got to be greater or equal than r2. You would have two r. One would be greater than the other one, or unless they are equal. Okay? If you have two numbers, you got to define the biggest value one to be r1 and the small value one as an r2. The thing is that we are going to, for the answer, we are going to use the cases. We have three different cases, depends on the r value, in order to get the solution. The case 1 is that is r1 minus r2. This is in the textbook already. Okay, if r1 minus r2, the difference between r1 and r2, if it is not an integer, then you would get two answers, which is independent to each other. The first one is going to be in the form of summation of an times x minus x0 to the power of n plus r1. And the second one, it is going to be the summation of Cn times x minus x0 to the power of n plus r2. This is the simplest one because you've got r1 and r2, which is they are not the same number. And the differences between r1 and r2 is the number that is not an integer. Then the two solutions would be in this form. The case 2 is r1 equal to r2. Then the answer, the first answer is going to be x minus x0 to the power n plus r1. But for the second solution, it can be r2 because r1 and r2 are the same. So that means you put r2 in there, these two are not independent to each other, so that's why it can be the answer. So the second solution got to be this form. y2 is equal to y1 times natural log of x minus x0 plus the summation of Pn times x minus x0 to the power n plus r1. To be answered in this case, then you would know that y1 and y2 will be independent to each other. And then case 3. Case 3 says that r1 and r2, the differences between r1 and r2 got to be positive integer. If it is a positive integer, it's going to be in the case 3. Case 3 saying that y1 is equal to summation of an times x minus x0 to the power n plus r1. But for the second solution, y2 is equal to c times y1 times natural log of x minus x0 plus the summation of bn times the x minus x0 to the power n plus r2. So in that case, like case 1 is the simplest case. You just plug the value of r1 and r2 in order to get the recurrence relation. Then you would get the value of a1 is equal to an. When you put r1 there, you would get a. If you put r2 there, you would get b. b0, b1, b2 bn. Second case, you got to find, because now our r, they are the same. So that's why you got to find a way in order to get two different solutions which is independent to each other. So that's why this go like this. Case 3, you got to find the value of c.